In this tutorial, we will get started with Python development for robotics projects. Now, before we get started, it's important to note that we will be following the ROS2 Python style guide throughout this tutorial and future tutorials where we use Python. This guide is based on PEP 8, the official style guide for Python code, with some ROS2 specific modifications. And let's go and find the ROS2 Python style guide. I'm going to open up Firefox right now, go to Google, and let's type ROS2 Python style guide. And let's check it out. All right, first result. And we're going to click on Python. And you can see right here the guidelines. And to get more specifics, you can click on PEP 8 guidelines. Just to give you an overview, though, some of the main ones. So for indentation, we are going to use 4 spaces. You want 100 characters maximum per line. For strings, we are going to use single quotes. For your imports, like when you're importing a library, you want to put that at the top, group by type. We are going to use snake case for functions and variables. If you don't know what snake case means, we will cover that later. And we're going to use cap words convention for class names. I will also cover that later in the tutorial, so don't worry about what that is now. But those are the main highlights of the ROS2 Python style guide. Adhering to these guidelines will make sure your code is consistent with ROS2 projects in the community that use Python. All right, let's close that out. Open up a terminal window. And let's begin by creating a folder to store your Python code. Let's type the make dir command and P, and then let's type the tilde /documents/Python_tutorial. Enter. And let's move to it. CD /documents Python tutorial. And now we're inside our Python tutorial folder. Now, for those of you who will be using Visual Studio Code for your Python development, which I highly recommend, you are going to type code and then the period. Otherwise, you can just open up your favorite code editor. All right. Just close all of that. Some stuff I had on earlier. So now we are inside our Python tutorial folder. And the first thing you are going to do is configure these settings. So click on the Extensions tab, and let's install some stuff right now. The first thing we're going to install is Auto PEP 8. So in the search bar, type Auto PEP, P-E-P, and then 8. And you want to install the version made by Microsoft. I already have it installed right now, but you would click Install. You're going to find a little button right there that says Install. The next thing you're going to install, when that is done, is Pylint. Don't worry about what these are right now. So P-Y-L-I-N-T. Okay, and you're going to also install the version made by Microsoft. Click the Install button right now that you see next to Pylint. I already have it installed, but you would click Install there. Once you have done that, you need to go to File, Preferences, and Settings. All right, follow along with me, click by click, keystroke by keystroke. And up here at the top, you're going to type Editor Rulers. Okay, and click Edit in Settings.json. And we've got these settings so far. You see, we're using Solarize Dark, tab size 2, and that's all we have for now. Now, follow me closely now. I am going to put the following settings into here. I'm going to overwrite all this with these settings right here. And I'm going to do a copy paste from my current settings file, which I already have set up. And you just need to make sure that you follow this exactly. So Control A, and here we go. Let's just go through this piece by piece. All right. You see the font size right now I set to 30, so it's nice and easy for you to see here in the screen. Terminal is going to be 30 as well. editor rulers 100, editor format on save true. And here are our settings. So you can see I set the tab size to 4. All right, this is very key. That follows the ROS2 indentation guidelines. I added some CPP, some C++ settings in a future tutorial. When I cover C++, we'll cover that. You notice that the tab size, the indentation size, is 2 spaces instead of 4. All right, and then I added some other default settings down here. And you can actually find these settings in the equivalent blog post that I have on my website for this, but just go through and just show that for a second here so you can type all of that. And if you need to pause the video, feel free to pause and you can type it in right here into the settings.json file right here. So workbench, editor, terminal, editor, all the way down. Make sure you get everything in here. Okay. And I'm going to stay on that for a little bit. For those of you following at home who want to pause and make sure you got it all in there. Put my cursor out of the way so you can see it. Okay, so once you have done that, you then need to save. File, save. All right, save the settings.json file. And you can exit out right now. We don't need it anymore. Now let's create a new Python file with intentional style issues to test our PEP 8 compliance setup. To test the configuration, create a new Python file named test_formatting.py. So how do we do that? Let's go click this button right here, the File Explorer, and you're going to right click, okay? Right click underneath the name of the folder, which is Python tutorial. All right. And click new file and let's name it test, T-E-S-T _ formatting, F-O-R-M-A-T-T-I-N-G .py. Press enter. All right. There's our new Python file named testformatting.py. All right. That's how you create a new file. And now let's put down some code with some intentional style issues. We're only going to use 2-space indentation. So let's do that now. Class, space, robot. Don't worry about what all this stuff is now. Okay. And 2-space indent, def, space, underscore, init, underscore. Put a space right there intentionally, comma, name, close parentheses. Okay. And now let's type under here, let's do a 2-space indent again. I'm going to do self.name equals name. Okay, go to the next line. Go to def, greet. Don't be worried about what all this stuff is now. We're just doing, you can see what we've done here is we've done 2-space indentation. Remember that the PEP 8 guidelines, we have to have 4-space indentation. So I'll show you the power of Visual Studio Code and those extensions and automatically formatting our code to make sure it is in accordance with the ROS2 Python style guide and PEP 8 as well. Self. Put a space in there and then a colon. All right, and let's do print, open parentheses, space, and then do hello. My name is, and then put the double quote there, and then plus self dot name, space, enter. Okay, and let's do my robot equals robot. And then let's do open parentheses and then double quotes and then R2D2. Go to the next line, and then we're going to do my, M-Y, lowercase, robot dot greet. Open parentheses, add a space in there. Okay? And so that's our code right now. Now, take a look at this. You see, we have 1, 2, indentation 1, 2, indentation 1, 2. All right? We haven't yet saved our file. Now, watch what happens. So you can press Control S right now to save, or you can go up here to do File and Save. And look at that. Automatically created the 4-space indentation because that's how our settings were saved up. So that's how you should see it. So you should immediately see some changes. And you also see some warnings as well, these little squiggly lines. So pretty cool, huh? So that's how your settings can automatically get everything formatted. So PEP 8, the Auto PEP 8 extension that you installed earlier, has automatically fixed the issues. All right, but some issues still remain, like these little squiggles, which if you put your cursor over, you can see the problems. Don't need to worry about that now, but that's pretty cool. All right, so we fixed our 4-space indentation. We're no longer 2 spaces, we're now 4 spaces. We also fixed some spacing that we had around our operators. You remember we added space in here with the self, and we had bad spacing here after the operator, that plus, that got fixed as well. Fixed the spacing after commas. We removed extra spaces inside parentheses that weren't necessary. So, but there's some problems that still remain that AutoPEP 8 doesn't specifically address. And these are highlighted by that PyLint extension that you had earlier. So like things like the class name are not good. It don't conform to, you see it says Pascal case, doesn't conform to the Pascal case, which is the same thing as cap words case. So variable names here, we have some issues. Let's see right here, no value for argument name. Actually, let's pull this out here. Okay. This should actually be out here. All right, and then we have function name issues. Missing a function docstring. What that's saying is it's missing some information about what that method does, and that's what you would write underneath that. You don't need to worry about that right now. So let's fix some of these issues manually by adding some extra stuff to the code. So Python is very specific. PyLint is very specific about documenting your code very well. So to fix some of this, let's go to type in first a heading for the code. What does this code do? So you type 3 double quotes. All right, I'm going to start with that. And let's say this module defines a simple robot class for demonstration purposes. 3 quotes. All right. Save that. Let's add a space there. Added a space there after that introductory comment. And now, what does this little squiggly line say? Missing a class docstring. And the class name robot doesn't conform to Pascal case, which is that cap words case. So let's fix both of those issues. And here is a docstring, just a description of what the code does. So you do the 3 double quotes, automatically the other 3 double quotes automatically fill in. And let's write just a simple summary of what this code does. Simple robot class that can greet. Period. Save. All right. And cap words case is like that, where the first letter of the class is capitalized and the second word, the first letter of the second word is also capitalized. So that's how this is the case. This is how cap words case looks. It's also called Pascal case. So what do we do here? We need to capitalize robot, save. And now that squiggly line goes away. We now have our doc string and we're using cat words case for the class. Again, don't worry if you don't know what classes are, all that, don't worry about it. But just showing you the power of how the Visual Studio Code can automatically format your code to be in accordance with ROS 2 style guide. So here, what do we have here? We are also missing a doc string, so we need to put that under greet. So let's put that, let's describe what this does. 3, and let's say print a greeting from the robot, period. Save. Okay. All right, and what do we have here? Attribute name doesn't conform to snake case. Ah, yeah, snake case. So snake case is like this. This is naming a variable, so you want to use snake case. So snake underscore case. Snake is like that. So if you have two separate words, you separate them like that, underscore, and make sure you're using lowercase for both of the words. So what do we do with this name variable? Oh, it's capitalized. We don't want that. So snake case, make it lowercase and save. All right. And now we need to do the same over here. That variable is lowercase. All right. So there we go. And we need to make a change down here because now our class name is in cap words case instead of lowercase. All right. You notice no more squiggles now. Pretty cool. So after making these changes and saving the file, you should see no more warnings at all. So now let's go to View and Terminal. All right. And let's make this bigger. And let's see, it says no problems have been detected in the workspace. So we have no more problems here. No more problems, which is pretty cool. By using AutoPep 8 and Pylint in VS Code, we've set up an environment that helps us adhere to the ROS2 Python style guide. AutoPep 8 automatically handles many formatting issues, while Pylint provides additional guidance on style and best practices. Remember, while these tools are extremely helpful, they don't catch everything. It's important to understand the principles behind the style guide and apply them as you write your code. In future robotics projects, this setup will help you write clean, consistent Python code that adheres to ROS2 standards, making your code more readable and maintainable. Now, finally, let's run the code. Look for Run. It's a triangle button in the top right. All right. Click this button. Make sure you've highlighted your Python file, and let's click Run. And there you can see the output in the bottom, and it says, "Hello, my name is R2D2. You have just successfully run your code." We also could have run it like this. So go to your terminal window, make sure you are in the Documents Python tutorial right there. And first, let's try running the code. Python 3 and then test formatting.py. There we go. Hello, my name is R2D2. So congratulations, that's your first Python program. X out the terminal. In this section, we will learn how to create and use variables in Python. Let's start by clearing this out by typing clear. Let's close this program out just to clear some of the clutter. So what is a variable? Variables in Python are like containers. They store data values. Unlike some other programming languages, Python has no command for declaring a variable. A variable is created the moment you first assign a value to it. So let's begin. Right-click on the Explorer pane and type new file. Click new file and let's type robot underscore variables dot py and press enter. Robot underscore variables dot py. All right, and then press enter. So in the new file, let's type robot underscore name equals, remember single quotes for PEP 8, ROS2 Python style guide, and we're going to name our robot Automatic Addison. and click Save. All right. I just typed Control C. So hold down Control, sorry, not Control C, Control S. So hold down Control and press S to save. All right. So here, robot name is a variable, and we've assigned it the value automatic Addison, which is a string. Python knows the type of the variable based on the value it's given. This feature is known as dynamic typing. You can also store numbers in variables. Let's create an integer variable and a floating point variable. So robot speed, robot underscore speed equals 5. There's our integer. So let's type a comment. In Python, comments start with the hash, that pound symbol, and type space. This is an integer. All right, now let's do our floating point value, robot underscore accuracy equals 99.9. This is a float. All right, and save. So remember, the pound symbol right here is how you create comments in Python. And comments are notes within the code that Python ignores when running the program. We can use variables to perform calculations. For example, let's perform a calculation. Let's say we want to increase the robot speed by 3. We can do so like this. Robot speed equals robot speed plus 3. All right, print robot speed. And the great thing about Visual Studio Code is when you start typing different words or names, you have the auto completion or auto suggestion that comes up. So now run the code. And how do we run the code? We click this up top, this play symbol up top, and I get 8 for the output. So you see, we started with 5, robot speed 5, and we added 3 to it to get 8. Get 8 down here. And notice how we use the same variable to update its own value. Python also allows you to create multiple variables in a single line. Here's how you assign different robot parts to different variables simultaneously. So let's go down here. We're going to type arm, comma leg, comma head equals. That's an assignment operator, that equal sign, and we're going to say arm bot. So single quote, arm bot, and then comma, leg bot, and then comma, head bot. Save. And now let's print that out. So print arm. Next line, print leg. We use the open parentheses right there for the printing. And then print open parentheses head. Okay. And press down Control, type S, or you can go to File and Save right here to save your program. All right. Now run the code again by pressing this play button in the upper right. So 8, armbot, legbot, headbot. You see, we printed the value of those variables, arm, leg, and head. So armbot was assigned to arm, legbot was assigned to leg, and headbot was assigned to head variable. Finally, variables can be reassigned to different data types. For example, let's say we want to reassign robot speed, which is currently an integer. We want to reassign that to a string. We can do so like this. So robot speed equals single quote fast, F-A-S-T. And now next line, let's do print, open parentheses, robot. And we've got go down, use the arrow button, press enter, robot speed. Okay, so we started with an integer of 5 assigned to robot speed. We then updated the value to 8 by adding 3. And now we're just going to totally assign robot speed to this string, this fast string. All right. And then we print it out to the terminal again. So click run again and let's see what we get. You can see fast right there is what we came out with when we did print robot speed. And just like that, robot speed now holds a string instead of an integer. Okay, let's clear out the terminal. Clear. And now let's learn about data types in Python. In Python, data types are the classifications we give to different kinds of data. Understanding them helps you manage how Python will process your data. Let's look at the most common data types used in Python. Let's right-click on the File Explorer over here, New File, and type robot underscore data underscore types dot py. Enter. I can close out that program. Okay. So let's type this code. Distance equals 120. That's our integer right there. So these are whole numbers with no decimal point. And I print distance. All right, and let's check the type. So check the data type. Let's add a space after that. Print, and then use the type operator, open parentheses, and distance. Save. All right, and let's click run. And you can see that we have 120 and the class is integer. It's an integer data type. Next is the floating point number. So let's do speed equals 25.5, print speed, and let's check the data type. And let's do print type speed. Save. Click run, and we see it's a float. We see 25.5 there with the decimal point is a floating point number. Now let's take a look at strings. Remember, strings, or str in Python, they are sequences of characters used for storing text. So in Python, you enclose strings in quotes. So let's do that now. Robot underscore name equals automatic Addison bot. Next line, let's do print robot name. And let's do check the data type, print type operator, and we do robot underscore name. Save. Now let's run it to see the output. So automatic Addison bot is our string class string str right there. Let's clear it out, make things look a little clearer here. Now let's look at a Boolean. What is a Boolean? A Boolean, or a bool in Python, represents one of two values, true or false. This data type is useful when dealing with conditions in your programming. So let's get some experience with that now. We will type is underscore active equals true. So true is one of the Boolean values, the other one being false. And then the next line, we do print is active. Check the data type. Add a space there. And now let's do print type is active. Okay, save. Let's run it. Click that. And so we have true bool. All right, now I'm going to change it to false. Save and run again. So now false, Boolean. So true or false, that's Boolean right there. Let's clear it out. Now let's take a look at lists. Lists are ordered collections of values that can hold a mix of data types, and they are mutable, meaning you can change their content without changing their identity. So we will create a list with the name components. So components equals open bracket, sensors, and then we'll type motors, and then we'll type camera. So a list there, list of strings. Check the data type, print, open parentheses. I'm going to do type components. Okay, and let's run it. So you see, we now have a list right there. And let's type something else. Let's print out the contents. Before that print type, we're going to do components here. Enter, save. Let's run it again. So you see, we can see our list of strings, sensors, motors, and camera, 3 strings. And then the type is a list. Clear. So let's look at tuples. Tuples are similar to lists, but they are immutable, meaning once they are created, their values cannot change. So if you want to create a list whose values does not change, use a tuple. Let's create one now. Under here, we're going to type dimensions is the name of our tuple, equals. And then open parentheses, and I'm going to do 20, 30, 40. So it's a tuple of integers. Let's print out the values. And then below that, let's check the data type. Print, type, dimensions, save. And in the upper right, let's run it. So you can see we have 20, 30, and 40. The contents of our tuple are output to the screen, and the type is tuple. Now let's look at dictionaries. Dictionaries are an important data structure in Python. You'll use them a lot over your robotics career. Dictionaries, or DICT, D-I-C-T, store key value pairs and are extremely useful, again, for storing data. They're kind of like a database. Think of them like a database for storing data. So let's create our dictionary. So I'm going to call our dictionary robot underscore specs. That's the name, assignment operator. And for the dictionary, we need an open bracket like that. All right. And then our key, first key is going to be called name. And the value of name will be the string Autobot. Okay, that's our first entry into the dictionary. And the second entry is going to be a key value pair. Our key will be speed. And we'll do a colon right there. And then just to the right of the colon, you put the value. So the format is key, colon, and then the value. That's the format for a dictionary entry. All right, so speed, and I'm going to say 25.5, our floating point number. Let's print it out. Print robot specs. And let's check the data type. So check the data type. And we will type print type robot specs. Press the down arrow. Save. Now let's run. So you can see we printed out our dictionary there. We have our 2 key value pairs. My battery is running low, so let me plug in my PC. Okay, so we've got our dictionary there, name, Autobot, and then speed 25.5. 2 entries into our dictionary, and the type is dict. Now let's explore the concept of casting in Python. Casting is important when you need to specify or alter the data type of a variable in your code. This is particularly useful in robotics when you need to ensure that data types match expected parameters for functions or calculations. So let's clear out everything in our terminal. Let's close this file right now, and let's right click over here underneath the folder name and click New File and type robot underscore casting, casting .py. Enter. Robotcasting.py. So let's type some code in here. Speed underscore str equals 30. So in that first line, you create a string, and the value of that string is going to be the string 30. And let's do print speed string. And let's print out the type, and we should expect string for the type. So print type speed string. Save. Okay, and now let's do this speed string. Actually, let's call this speed int. Make it clearer. We'll do equals int. This is our casting right here. We're converting this string to an integer by enclosing the string in the int casting operation right there. So int, open parentheses, and then speed string, the name of the variable that we want to convert. Now let's do print speed int. And then on the next line, let's type print type speed int and close that parentheses out there and then save. Okay, so there's the program right there. If you need to pause the video to get all that code, you can do that. And so what this code does is it converts the string 30 to the integer 30, enabling operations. So you can do the run button right now, press run, and you can see that we have 30, which originally begins as a string, and then we did the casting operation, and we converted it to an integer. So now that 30 you can use for actual addition, subtraction, multiplication, division operations. You couldn't do that if it was just a string. Let's clear. Similarly, if you're working with floating point numbers but need to convert them to integers for functions that do not accept floats, you can do the following. Write this code. Distance underscore float equals 120.5. That's our floating point value. And then let's do print distance float. And let's do print type distance float. Save. All right. So original float value, and we want to cast that to an integer. Distance underscore int equals int distance float. There's our casting operation. And let's print the value, print distance int, and do print type distance int. Okay. And now we are going to run it. So what happened here? We started out with the floating point value, 120.5, which is a float. We casted it on line 13 right there from a float to an integer. And you can see the new value is 120, and the type is an integer. So by casting to an integer, you truncated the decimal part to all that 0.5. You truncated. It means just stop right after the 120. Finally, let's look at converting numbers to strings, which is common when you need to concatenate numbers to strings for messages or outputs. So on line 17, we're going to do age equal 5, age underscore str equals string, age, and let's type message equals the robot is, let's put a space there, plus age underscore str plus years old, period. Save. And now let's print message. Okay. And let's run it. So you see what happened there? This cast the integer 5 to the string 5, making it possible to construct the full message string without errors. The robot is 5 years old. So let's see what happened if we get rid of that casting. What would happen? Will we still get the same output? Now we save and let's run. See, now we've got errors because you can only concatenate a string value. You can't put the integer like that right there. You have to first cast it. So you have to cast the integer to a string. Now run it again. Went just fine. The robot is 5 years old. Now let's see how to work with output in Python. Managing output effectively is important for debugging, monitoring the state of your robotics applications, and providing interactive user experiences. Let's get started. Right-click over here on the left side. New file, robot underscore output.py. Let's close that old program there. So in Python, the print function, which you saw earlier, is the most common way to output data. Whether you're outputting simple messages or complex data structures, print can handle it all. Let's look at some examples. We'll start with a straightforward example. I will do print, open parentheses, hello, robot world, exclamation point, save. Click run. Let's clear that out first. Now click run again. Hello, robot world. So that code right there on that line sends the text hello robot world to the console, which is useful for simple notifications about the program's status. You can also use the print function to output multiple items in one line by separating them with commas. Let's try that now. Robot name, robot underscore name is what I just wrote, equals automatic Addison bot. Next line, let's do task status equals active. And let's do print robot name, comma, robot name, comma, single quote, status, and then comma, task status, task underscore status. Press enter right there. Okay. So now let's press the run button, and you can see we have robot name, automatic Addison bot, status, active. You see how we use the print function and we just added different strings, comma separated like that, and it created a single string all on one line of the output. So for more complex outputs, you might want to format strings. Python's string formatting capabilities are powerful. So here's how you can use formatted string literals, also known as F strings. F strings. You may have heard it before. So let's go to battery level equals 85. And on the next line, we're going to type print F, that F symbol for formatting the string. We're going to do battery level. Let's type a colon here, open bracket, battery level, name of the variable, and the percent sign right here. Okay, so you can see all of that. So declaring the variable right here, battery level, assigning a value of 85, integer value, and now we're going to print it using the format F string symbol right there, and then battery level, and then the variable name inside these curly braces, actually curly braces. I think I said brackets earlier. It's curly braces, and then the percent symbol right there. So showing the percent battery level. So what this does is it injects the value of battery level directly into the string, making it simpler to construct detailed messages dynamically. So now we run the code, and here you can see battery level 85%. 85 gets injected in there automatically, and then the percent symbol after that. Now, sometimes you may want to redirect your output from the console to a file. This is especially useful for logging data that you want to review later. So let's take a look at how you can do that. Clear. We'll go with open parentheses, log.txt, comma, single quote, A. Okay, and then as file, colon. And let's do print an error occurred. And let's do file equals file. So what does this code snippet do? This piece of code opens log.txt in append mode, and it writes an error occurred to the file instead of the console. So let's run it now. Okay. So now you can see our log.txt right there. You can also go to a terminal window, move to the folder, type the dir command, and you can see log.txt. We also in here can just do it straight in here. You can see log.txt, and in Visual Studio Code, you can also see log.txt. Let's click on it right now and see what's in there. You see an error occurred is now inside the file. So you see that? The output was appended to the file. So that's it for this tutorial. You've taken your first big step into Python programming. Thank you for following along with me, and I will see you in the next tutorial. Keep building.